We physicists have waited 100 years since 1916 for this photograph.
They said that the James Webb Space Telescope saw a big object moving toward Earth from about 10 light years away. The James Webb Space Telescope has opened up a new era of astronomical finding by giving us looks into the farthest reaches of the universe. Reports say that this cutting-edge camera has taken the first real picture of the inside of a black hole, showing that it is now much more powerful than ever before. Not only scientists, but also well-known people like Elon Musk and Michio Kaku have paid attention to this important event. This kind of finding is more than just interesting, it touches on the deepest puzzles of space-time, matter, and the rules of physics. Before we start, click like and subscribe to get more exclusive stories. People used to think that black holes were the most mysterious and hard to find things in the universe. They are places in space where gravity is so strong that not even light can escape. They are made up of the remains of huge stars that fall apart due to their own gravity, leaving behind a singularity, a point with infinite density, and an event horizon, the edge beyond which nothing can return. Scientists have had ideas about what lies beyond the event horizon for many years. Mathematical models and computer simulations have shown that black holes might hold secrets about how space-time and gravity work. We had only seen black holes indirectly up until now, by looking at how they affected nearby objects and the radiation they gave off from the rings of gas and dust as they shook. The Event Horizon Telescope, EHT, took a picture of the supermassive black hole at the center of the Messier 87 M87 galaxy in 2019. This picture was hailed as a great success. But the picture was actually a blurry, donut-shaped ring of light around a dark area in the middle. This was the event horizon's outline, not the inside of the black hole. With its unique infrared abilities, the James Webb Space Telescope is a huge step forward from what the EHT could do. The James Webb Space Telescope is about 1 million miles away from Earth and is meant to look deeper into the universe by picking up light from the oldest galaxies and showing features that have not been seen by other telescopes. The picture it took of the inside of a black hole is the first straight look beyond the event horizon in the history of science. Not only has this discovery caused a lot of joy, but it has also led to a lot of new questions about what reality is. Elon Musk, a tech billionaire and space entrepreneur, was quick to say how excited he was about the finding. Musk is known for his big plans for space travel through SpaceX. He has talked a lot about his interest in black holes and how they might help us understand the world. The importance of this finding fits with Musk's interest in the unknown and the limits of what scientists can know. He thought that the picture could give us information that would help us make technological advances and maybe even help us figure out how to fly to other planets in the future. Musk has always been hopeful about exploring beyond our solar system because he believes that learning about the universe's harshest places, like black holes, will eventually lead us to new discoveries. The famous theoretical physicist and futurist Michio Kaku also spoke about how important the James Webb discovery was. Kaku has long pushed for making physics more accessible to the public and for simple science ideas to be understood by everyone. He has talked a lot about the ways that black holes can help us find a way to combine all the rules of physics. His argument is that finding the inside of a black hole could help solve one of the biggest scientific mysteries of our time, the clash between general relativity and quantum physics. Einstein's theory of gravity, called general relativity, explains how heavy things bend space-time and control the movements of everything around them, even light. While quantum physics, on the other hand, describes how particles behave at the smallest sizes. Both ideas have been proven to be true in their own areas, but they don't work together at all. With their strong gravity and very small singularities, black holes are the perfect place to test a unified theory, which is sometimes called the theory of everything. Kaku thinks that looking into the center of a black hole could show us the quantum structure of spacetime, which could help us understand the universe's most basic forces better. The James Webb Space Telescope took the first real picture of the inside of a black hole. This picture is expected to change many long-held beliefs about these huge cosmic objects. Over the years, scientists have thought that the inner event horizon, a place deeper inside the black hole where the known laws of physics might not apply, might exist. The picture taken by James Webb seems to prove that such a place exists, but it also adds to the complexity of the situation. Early studies show that the space inside the black hole might not be the smooth, empty void that many people thought it would be. Instead, it might be a very fluid place where quantum changes cause ripples in the very structure of spacetime. This finding is important for both theoretical physics and the study of astronomy as a whole. Black holes are thought to be very important in how galaxies form and change over time. Learning about the insides of galaxies, like our own Milky Way, could help us figure out how they formed. Also, black holes might hold information about what will happen to the world in the end. Some ideas say that black holes might finally disappear through a process called Hawking radiation, which is named after the famous physicist Stephen Hawking. If this is true, black holes might lose mass slowly over time until they disappear, leaving only radiation behind. The picture taken by the James Webb Space Telescope could help scientists test this idea and find out if black holes really do disappear or if they could live on forever in some way. This finding has effects that go even further into the world of theoretical science. Some experts think that black holes might be doors to other dimensions or worlds. This idea comes from the idea of a wormhole, which is a made-up tunnel through spacetime that could join faraway places in the universe or even worlds that are not connected to each other. If these kinds of structures are inside black holes, they might be able to help us move across very long distances in space or even through time. At the moment, there is no proof to back up these claims, but the picture taken by James Webb could be the first real data that lets experts test these ideas. One of the most exciting things about this finding is that it makes new study possible. In the years to come, the James Webb Space Telescope will likely keep looking at black holes, improving its methods and getting even clearer pictures. Scientists will learn more about the strange forces at work inside these cosmic giants with each new observation. The information the James Webb Space Telescope gathered could also be used to help create new tools and devices that will allow us to look even deeper into the universe. Based on how well the James Webb Space Telescope worked, future space projects could use even more powerful cameras or send probes close to black holes to collect more data. This picture of the inside of a black hole also makes me think about the nature of reality itself. Black holes make us think about what space and time mean and push these ideas to their limits. Spacetime curves forever around the singularity at the center of a black hole. At this point, the rules of physics as we know them no longer apply. This makes me think that black holes might help us figure out what the world is really like beyond what our present theories can explain. The find makes many people think about how much we still don't know about the universe. Even though science has come a long way over the centuries, the world is still full of secrets. For example, no one knows what dark matter and dark energy are or if there is life on other planets. The picture that James Webb took of the inside of a black hole shows how curious and resourceful people are. It shows that with the right tools and persistence, even the hardest questions can be answered in the end. Scientists from many different fields work together on the James Webb Space Telescope. This shows how important it is to do study across disciplines in order to fully understand the world. Astronomers, engineers, mathematicians, and physicists have all worked on the James Webb Space Telescope and helped look at its data. Working together has not only helped us learn more about black holes, but it has also shown how powerful it is to push the limits of what we can do as a science community. One of the most important events in the history of modern science was when the first real picture of the inside of a black hole was taken. In a big way, it changes how we think about the world and gives us a look into a part of space that we used to think was totally out of reach. This accomplishment brings us closer than ever to solving the riddles that have long-ringed black holes. It not only gives us a better understanding of these mysterious cosmic objects, but it also gives us a chance to look into the basic rules of nature in a way that has never been done before. One of the most important and direct effects of this finding is that it might help us learn more about the event horizon, which is the edge of a black hole beyond which nothing can escape. The James Webb Space Telescope took this picture. Before this picture was taken, black holes were mostly studied in other ways. Researchers could only guess about their features by looking at how things and light behaved near the event horizon. But this new picture gives us a clear picture of what's inside, giving us information that we couldn't have imagined before that could completely change how we think about the physics at work in these harsh settings. Matter and energy inside the event horizon are hit by gravity forces that are so strong that space and time don't work the way they should. The theory of general relativity, which has been the basis of our knowledge of gravity for more than 100 years, accurately predicts how black holes will behave, but it doesn't fully explain what happens inside these objects, especially in the singularity. The singularity is the point where there is no more mass and no longer any rules of physics that can be used. The James Webb Space Telescope took a picture of the inside of a black hole, which makes it possible to test these ideas in ways that weren't possible before. This important discovery could also have big effects on the study of quantum physics. Michio Kaku said that black holes are a unique way to look at how general relativity and quantum physics might be able to work together. For decades, scientists have been trying to figure out why these two important ideas in modern physics don't seem to go together. Quantum physics describes how subatomic particles behave, while general relativity describes how big things in space behave. Because black holes have singularities that are infinitely dense, they are right in the middle of these two sets of rules. This makes them perfect for trying a single theory of quantum gravity. In time, scientists may be able to use pictures of the inside of a black hole to find out about the quantum features of spacetime itself. Some theories say that spacetime is not a smooth continuum at very small sizes, but is made up of discrete quantum bits of energy. Quantum gravity is the study of how the fabric of spacetime might behave at the Planck scale, which is the smallest distance that matters in physics. This idea is at the heart of quantum gravity. If you look inside a black hole, you might see patterns or events that provide clear proof for this quantum structure. This could lead to answers to long-standing questions about how reality really works. One of the most important things this finding does is change the way we think about time. General relativity says that time is not a set and unchanging constant. Instead, it is a dimension that can grow and shrink based on the gravitational forces at work. Time slows down a lot for things close to the event horizon because black holes have so much force. This is called time dilation. Looking into the center of a black hole, where gravity is even stronger, might give us the most correct information we have yet on how time dilation works. This could help us learn more about how time flows in extreme situations, which could lead to a better understanding of how time, space, and gravity are connected. The find brings up the so-called information paradox again, along with the idea of time dilation. Stephen Hawking famously said in the 1970s that black holes might be able to give off radiation, now called Hawking radiation, that would finally evaporate and go away. But this radiation seemed to go against another well-known principle of physics: information stays the same. Quantum theory says that details about a system's first state should never be lost, even if the system changes or breaks down. But if black holes could fully disappear, it made me wonder what would happen to the data about the things that fall into them. Is it lost for good, or does it get away? The picture taken by the James Webb Space Telescope could help solve this puzzle by giving us new information about whether black holes really delete data or if it is kept safe in some unknown way. There are more fanciful ideas about the nature of reality that are based on the idea that black holes might store information. One such idea is that black holes could project data stored on their event horizons like holograms. Based on the hologram principle, which comes from string theory, this idea says that all the information inside an amount of space can be shown on the edges of that space. In this case, black holes might follow this rule, which could mean that their huge, complicated innards are like representations of the data stored on their event horizons. Taking a picture of the inside could help test these ideas. It would be the first real-world proof of the holographic principle and change the way we think about spacetime and information theory. This finding doesn't just have implications in the area of physics. People have long thought that black holes are very important to how galaxies change over time. People think that supermassive black holes, like the one at the center of our galaxy, Milky Way, can change how stars and other celestial objects form and behave on a cosmic scale. A picture of the inside of a black hole could tell us a lot about how these very large things interact with the world around them. It might show how black holes take in matter, how they send out powerful energy jets, and how they change the structure and motion of galaxies as a whole. In addition, black holes may help us figure out some of the most puzzling things in the world, like dark matter and dark energy. One of the biggest puzzles in current astrophysics is dark matter, which makes up about 27% of the universe's mass. It can't be seen directly because it doesn't give off, absorb, or reflect light. However, the way its gravity affects things that can be seen suggests that it is there. With their strong gravity pull, black holes may give us a new way to study dark matter by showing us how it interacts with normal matter in very harsh conditions. In the same way, dark energy, which is speeding up the growth of the universe, might be connected to things that happen inside or near black holes. The information that the James Webb Space Telescope sent back could hold important clues that can help solve these cosmic puzzles. The finding also makes people wonder what kinds of technology advances could be made by learning more about black holes. The fact that Elon Musk is so excited about the picture of the inside of a black hole shows how science discoveries can lead to new technologies. Musk, the founder of SpaceX, has long pushed for more human space travel. He knows that understanding black holes could lead to new ways of moving things or making energy. Some ideas say that black holes could be used as powerful energy sources because their huge gravity fields make it possible to get energy on a huge scale. This idea is still just a guess, but the picture of the inside of a black hole could be the first step toward looking into these options in more detail. Science fiction stories have often used black holes to show doors to other worlds or even ways to move through time. These thoughts may seem crazy, but they are based on real science speculation. Some people think that wormholes, which are made up tubes through spacetime, could form when black holes bend spacetime very much. If these kinds of structures do exist, they might provide a faster-than-light route through the world or even lead to trips to other universes. The picture of the inside of a black hole might be the first real evidence to test these ideas, giving us new information about whether wormholes are real or just thoughts. The sense of wonder and awe that this finding brings is one of the best things about it. With their strong gravitational pull and the power to bend time and light, black holes make us question even the most basic ideas we have about how the universe works. People used to think that these things were impossible to get into, but now we can see inside one of them. This shows how creative people can be and how powerful science study can be. The James Webb Space Telescope has already shown that it is one of the most important science tools of our time, and this picture is just the start of what it can do. The James Webb Space Telescope will keep looking at black holes and other strange things in space, getting more information and helping us better understand these strange objects. Scientists from all over the world will be working to look at the data and come up with new ideas to explain what they see. The picture of the inside of a black hole is only one piece of a much bigger puzzle. As we continue to study the world, we will likely find many more amazing things. The joy over this finding also shows how important it is for people to be interested in science. People like Elon Musk and Michio Kaku are very important for explaining hard science ideas to more people and inspiring the next generation of scientists and engineers. The picture of the inside of a black hole has captured people's attention in a way that not many science findings can. It reminds us all of how curious and exploratory people can be. The James Webb Space Telescope's picture of the inside of a black hole is more than just an amazing sight. It is a science breakthrough that takes us to a new area of space and physics that we thought we could never see. As these visual data are put through thorough studies, they will have effects on many areas of study, from astronomy and astrophysics to quantum mechanics and even philosophical ideas about how the world works. Many people were initially interested in the stunning images, but the most important thing about this discovery is that it could lead to completely new ways of thinking about the structure of spacetime, the mechanics of gravity, and the very limits of what humans can understand. To fully understand how big this accomplishment is, it is important to look at how black hole studies have changed over time. Einstein's general theory of relativity first forecast black holes in the early 1900s. Later, they changed from theoretical concepts to real things that could be found by studying how they affected matter around them. Astronomers and scientists have used many tools over the years, from X-ray telescopes to gravitational wave monitors, to figure out if black holes exist and study how they behave. But these detections were always far away. We never saw how the inner parts worked. That has changed thanks to the James Webb Space Telescope, which has amazing sensitivity and can see across a wide range of bands. Scientists can now see inside a black hole thanks to the James Webb Space Telescope. This is the first time that the normal rules of physics don't seem to apply. One of the most important effects of this discovery is that it opens the door to getting direct physical proof for some of theoretical physics's more speculative ideas. For many years, black holes have been used to test some of the most extreme scientific theories, such as those about string theory, quantum gravity, and even the idea of multiple universes. By being able to look straight into the center of a black hole, scientists can test these ideas in ways that were previously unimaginable. For example, in string theory, black holes are thought to be the key to understanding how the universe's most basic building blocks work. The idea behind string theory is that particles are not points but tiny, moving strings at the smallest sizes. Because this idea is so complicated mathematically, it has been hard to test in the real world. However, black holes are perfect places to test these extreme circumstances. Scientists may be able to find signs of quantum changes that would help them figure out if string theory is true by looking at how matter and energy behave as they get closer to the singularity of a black hole. The picture of the inside of a black hole could show how spacetime acts in these situations, which could be the most clear proof of string theory's statements from science. This finding will also help a lot with the study of quantum gravity, which tries to make sense of both general relativity and quantum physics. Modern physics has two main models that explain the structure of the universe on a large scale and how particles behave on the smallest sizes. Attempts to combine them into a single theory that makes sense have failed. A unified theory can really be put to the test in black holes, especially their singularities. The singularity, where the mass of matter goes to infinity, goes against the laws of general relativity. Also, the quantum effects that should control particles in this region have not been found. By giving us a clear view of the space inside a black hole, the James Webb Space Telescope has made it possible for us to learn more about this elusive unified theory. This could be the start of the next big change in physics. This finding could have a huge impact on the idea of spacetime, which is at the heart of both general relativity and quantum physics. The general theory of relativity by Einstein says that spacetime is a four-dimensional cloth that is bent by the presence of matter and energy. In the very harsh conditions inside a black hole, however, this bending gets so strong that space and time are thought to bend in very strange ways. The James Webb picture gives us a unique chance to see these effects happening right now, which gives us new information about how bent spacetime works and how it reacts to the very harsh conditions inside a black hole. Scientists may be able to make new models of spacetime that account for these distortions by studying the exact patterns of light and matter as they interact with the event horizon and singularity of a black hole. This could lead to groundbreaking discoveries about the structure of the universe. In addition to helping us understand how spacetime and gravity work, studying black holes might also give us new ideas about how the world came to be. Some ideas say that black holes may have been very important in the creation of the universe, working as catalysts for the growth of galaxies and stars. A picture of the inside of the black hole might show proof of these processes. This would give us a look into the early universe and help us understand how the complicated structures we see now formed. It would be great if you could like this movie and follow our station. Also, could you leave a comment below and tell us what you think the inside of the black hole will show us? Please let us know what you think. It was fun to watch. See you next time.